Hello, I'm Robert, a fact checker and science blogger, and helping people scared of many things. And this is about the UK's new variant, and it seems so scary on the news, but it's actually, it's not really a new thing at all. It's just, if it is a change, it's a slight change from what we have already. It's the same way of protecting yourself. It doesn't seem to be seriously more severe. It doesn't seem to evade vaccines. And the main question is whether it is slightly more infectious. It can't be hugely more infectious either, because it's been around here since September, and if it was hugely infectious, it would have, look how fast the original COVID-19 spread. It would have been everywhere by now. So it's a slight increase in how infectious it is, if it is at all. Now, the evidence that it's more infectious is not very strong. It's really it's just suggestive. It's quite weak. And the data has just come out, the paper's just come out a few hours ago, and this is what they have as their evidence. So you can see these are the different weeks: 44, 45, 46, 47, 48. Now, if you go up this way, you've got more of the new virus, and that's over 3/4. If you go this way, you've got less of it. If you go this way up, then it's got a higher multiplicative advantage. That's like the R0, and it spreads more easily. And if it's down here, it spreads less easily. Each of these dots is a region in the United Kingdom. So now if we have a look at that, as you can see, the two regions with the most rapid spread in week 48, which is last week of the data, have hardly any virus. It's possible they have none, because this is just the proportionate FSG negative, and that's a proxy. Some viruses are like that anyway, some of the other variants. So it's possible that there's none of the new variant in those two regions, and they have the highest reproduction advantage of all of it. And then if you go and look down here, then the one with the most of the new virus detection, it's only a little bit above 1. And their line that they've drawn out as being kind of the average is quite a way above that one. And so they're doing it basically really about the data here. But there's a huge amount of scatter. So it's not that conclusive. And these are the earlier weeks. They're also contributing, and all the data here is really quite small amounts, like 20% of the new virus. And there isn't much data with very high percentages. What there is doesn't, because remember, there could be an advantage due to people's behaviour, that it was below 1 during the summer, and then long before this virus came along, then it was, or became a significant factor, then the numbers were going up because the R0 went above 1. And then that was up for quite a long time. Then they managed to bring it down with another lockdown, and then they eased the lockdown and started coming up again. And during all these things, then this has been, this now 1.1 could easily be just humans just not being very careful. So that picture there it's just suggestive. It suggests more research. It's not very conclusive. And to say why I say that, remember, I'll bring up this talks deliver babies thing. So the problem is that we have lots and lots of studies going on, all looking at COVID-19, hundreds of them, thousands of them probably worldwide, doing exactly this sort of a thing. And if you have lots of those, you'll get spurious coincidences come up from time to time, just through statistical variation. And here's an example of a paper that was done. The title of the paper is Talks Deliver Babies, P equals 0.008, which means almost certain. And it's not meant to be a proof that storks deliver babies. It's a paper to show how these sort of correlations can lead you astray. And so these are the countries in Europe with breeding storks. This is the number of breeding storks they have, and then this is the birth rate. And it turns out that the countries with most breeding storks have a higher birth rate. And so you could use that to try to prove that storks deliver babies. So that's an example, and we all know that that's not the reason for that. And you can ask if there's some other reason. There's some speculation in the papers whether there's some other reason why there'd be a correlation like that. But for sure it's not that storks deliver babies. If you go and look back at this one, then there could be many other reasons for the correlation. It could just be a random chance, and that could be the case for storks deliver babies as well. And it could also be that it's the other way around, that this virus got into some super spreading index cases, and then when there's an awful lot of high reproduction, then this one happened to be the index cases, and so it spread more. So anyway, and so what else have we got here? Well, these some of the things. I'll give some into space. You can go and look to find out more. This shows the other virus variants, and this one is going up like that. So these other virus variants confuse the picture a bit. But this is what the actual, if you do the actual sequence the entire virus, you'll find that that's how it's increasing. And so other countries, they have a little dropout like that of the S. They will just have to investigate. They'll have to do full genome sequencing to check and see if what they are observing is this. If what I've described here is not, it's not actually happening, if it isn't more infectious, we should find out in the next few weeks. They will discover maybe the correlation won't continue anymore in the United Kingdom. Maybe they find another country where it's remained low for a long period of time, and things like that. We'll get exceptions to it. That'll make it really clear eventually. But it takes quite a lot of time to do all the research to answer that sort of question. Personally, I'd be quite surprised if it's with the World Health Organization press conference. Mike Ryan was saying that it could be due to behaviour, it could be due to the virus, it could be a mixture of both. It could be the reason for the increased R naught, that is. As for the way it's spreading to the entire population, then here we are. It's not the first time by any means that a variant of a virus has spread rapidly until it fills the entire population. And this is the D614G, which was just one amino acid spread, but it seems to make it slightly more infectious. So get more viruses, and from each infection, and from each one virus going to more of them. And as you can see, this particular one went very rapidly through the population, and it's over about the same time scale. It had covered nearly 3/4 of the world. On the same time scale, this one covered 3/4 of the English regions, of some of the English regions, not all of them. Indeed, so this really looks quite a lot faster, because there were little subpopulations that were much faster with this. So, and that one, I think the jury's still out as to whether it's actually more infectious. And so I just want to look at other ways it could be done. And certainly for D614G, example of Ebola, first of all there's viral fitness, which means that once the virus gets into the cell, it produces slightly more viruses to come out and spread again. And if you start at the top with 36% of the new strain of Ebola and put it through some cells, just 9 times, you end up like that, just in one person's body. So it's just going through, and it's just a very slight advantage. It's only, but there's only 4% left, so it's only a very slight advantage. But by the time you've gone through the cells 9 times, there's only 4% left of the old virus. So if you had two viruses, the new strain of Ebola and the old strain, both got into your body, then what would come out of your body when you infect someone else would just be the new strain. And that could be what happens with this. And that would make it spread very quickly, so long as you've got a bit of mixing, where sometimes people are infected by more than one person at the same time. Or where one person has both viruses in them and gives them both to someone else. So that's one way that it could happen. Another way it can happen is that that it's easier for a virus to enter the cell, and so that means you need fewer viruses to infect the cell, and then that could make you be more transmissibility, that it takes fewer viruses from another person to come into you, but it doesn't have to. And there's another example from Ebola, where there was a virus that got into the cell more easily, but the young mutation did seem to improve the ability of the virus to infect cells, but when it was tested in animals, it had no effect on how well they shed virus or whether they spread which disease to others. So you could have a virus that can infect the cells more easily, but it doesn't mean you shed more virus, it doesn't mean you spread more. With the new variant, UK's new variant, then they did find that there was more virus in the nose, there seemed to be, in the nasal swabs. Again, I haven't got a detailed breakdown of the data, but they gave some figures. And, but that needn't necessarily mean that you're actually going to shed more, or that if you do shed more, it's going to be more infectious. Depends an awful lot on how the shedding happens and whether it actually makes a difference. Like, if you've got, say, 500 or 1,000, is it going to make a difference depending on how it spreads to the other person? So it's certainly not, it's not certain that there will be an increase in transmissibility. Even just like with the case of Ebola, you could have it spreads to the entire population without being more transmissible at all. It could just be it's fitter within the body, goes into cells more quickly, comes out of them more quickly, but it doesn't transmit from you to other people more quickly. And then it could just be chance on the super spreaders. So there we are, back to the beginning. So that's about all I want to say here. Many other things I could go into. Oh yes, just one more thing. And so, but most of you will have heard me say this before, many times. But just that I'm going to do another video about the 5 or 6 things that most people don't know. Hopefully, if you've been following my videos or my blog posts, you do know these things. And so anyway, but the main thing is that to continue to protect yourself. And it's exactly the same thing as before. If you're going to interact with someone, step back. Try and make that automatic, rather than making something you've got to keep deciding and thinking about during the day. Just whenever you socially engage with someone and you're talking, there's a possible exchange of droplets, immediately step back. It doesn't really matter how far. The main thing is at least 1 meter. And some people say 2 meters. Oh, that's gone blank. I wonder why that is. Oh yes, that's the other one. There we are. Yeah, so if you step back 1 meter, and just make it as habitual as click for your putting on your safety belt, that you don't drink and drive, and you look both ways when you cross the road, or doing up your shoelaces or anything like that. So all the things you do to protect yourself against COVID-19, the physical distancing, wearing your mask, and always wear the mask in particular situations, and don't touch the front of the mask. Look up. It's well worth looking up how you should put on a mask, how you should wear it, how you should just keep it you should keep it in something during the day, not just put it in your pocket. Keep it in an envelope or something. And so just make sure you know that, practice it, do it, And once you've done it like that a few times, you'll always do it like that. Same with washing your hands. You've got to wash your hands very thoroughly, around your thumbs, between your fingers, all of that. And if you look at the recommendations by Dr. Tedros, do that a few times, and you get into the habit of doing that. And wash your hands with soap. Soap is the best, really. It's better than alcohol rub. Yeah, if you use alcohol rub, if you haven't got the soap. Those are some of the main things. Anyway, I'll go into, and then if you isolate and quarantine, be sure to isolate properly and quarantine properly, and find out how to do that. Check up how to do that if you are either a contact, and then tell all your contacts. And so those are basically the things. Are quite simple, really. But that if we all did that, then it just would stop pretty quickly. If we all did those simple things. And also that you almost certainly know all your contacts because of the way it spreads. Within 15 minutes, you either know them or you met them at a gathering of some sort where the host of the gathering knows how to contact them. So if you test positive, then and you know your COVID case, then you should not wait for the contact tracers. Immediately ring up all your contacts and tell them that you've got COVID-19. That is, if you were in contact with them, talking without doing the proper physical distancing, closer than that, and sometime in the 2 days before you develop symptoms, then you want to get in touch with them and say, I talked to you a bit close the other day, and we talked for quite a long time, do you remember? And I've now got COVID-19, and if you want to protect your own family and household, then it'd be really probably a really good idea to isolate away from them. And if we all did that, then that would and support them as much as one can in doing that. We don't need the contact tracers, actually. We could stop it without doing the contact tracing if the general public did that. If that was really built in and everyone did that, then we can do the contact tracing ourselves, unlike most diseases. So anyway, those are my main things. I'm going to do a separate video on all that in a minute or two, well, maybe tomorrow. I'm not sure if I'll do it today, but about the 5 or 6 things that most people don't know, and the importance of doing those things, and how that could. The reason we are in lockdown is because people aren't doing those things, and that's basically it. I'll upload this. Any questions? If I've got anything wrong, do say, and we'll find out eventually. Anyway, yeah. So just keep doing the same things. This new variant really doesn't make it. It may be that there's actually nothing to it. It may be all just a bit of a false a red herring, or whatever you call it, where it was just they were confused by the fluctuation in the data, which happened to happen at the same time as they were looking at it. Could be any of these things. Anyway, we'll see. We'll soon know within a few weeks. We should know.